All right, so we've got Aaron. He is the boss specialist with Fierro. So, Aaron, we're at the Global MDN meeting here. So, what do you got going for us?
Out in Colorado, we've had a couple successes in the canning industry. So our idea for the booth was to showcase some of the things we've done in canning this year. This here is a 3D model of a PhD and Mac hybrid win. This is called a trip mandrel. And so on a can decorator, when there isn't a can in one of the slots, it'll trip the mandrel so it doesn't print onto nothing.
Oh, okay, gotcha.
And so what we've done here is we've mounted the bullet valve. Inside here is a cylinder that moves the trip mandrel.
Okay.
And so the real secret sauce is latency. And they used to have valves away from their cylinders. They used to have to program lag and algorithms.
Ah, okay, yeah.
And now that they have the valve directly mounted to the trip mandrel, we've lost all the latency and you get much quicker reaction times.
Yeah.
Our technology works good because our accuracy and repeatability in an application like this, they're doing 2,500 cans a minute. And so depending on what your air pressure is and how your valve's going to respond, if you don't have a balanced design, you could be several milliseconds off, which doesn't always sound like a lot, but when your whole cycle time is 20 to 30 milliseconds, being 5 or 6 milliseconds off is a really big deal.
A really big deal, yes.
So they've really bought into, and our technology fits really well in this industry, and that's what we're trying to show.
Yeah, and so just to be clear with everyone, so these bullet valves, you know, you've seen them in all sorts of fit, form, and function. So here it's the manifold mount, and so like Aaron was talking about, so typically sometimes they come into you know, their own manifold. We're here with the manifold mount. We're mounting it to this other custom manifold. So that way, the air is actually going through here into the actuator that's inside.
And they're four ways.
Four ways, yeah. Great. Very cool.
And then we're doing a TLD demo just to kind of show what an SMC does with pressure decay and how it reacts. And so you can see as we lower the pressure on the regulator, the energized response time, it opens slower and closes quicker. And if you were to lower the pressure again, that curve would get even steeper because it only has a spring return. And so when it has 80 psi to open, it opens really fast, but then the spring has to push back against it. And so at 80 psi, it closes slower. And then you knock it down to 40 psi, it'll open slower and close faster. And that's the definition of repeatability.
That's right. That's right. And so once again, the TLD is something that Mac came up with. Called the traveling lab demo, and so this way we're able to compare a competitor's valve to a Mac valve and show how, because we're since we've got the higher shifting forces, then we're able to have a much better, a much faster response time on the front end and the back end. So
precisely.
Very cool.
Repeatability.
Yeah, repeatability. That's so key here. All right, and then what else do we got down here, Aaron?
This is another project for this machine. Traditionally, they've always used 32 of these.
Okay.
And then we switched them over to 32 of these. Okay. So they're using individual Mac valves instead of individual SMC. And I said, how about we clean everything up? That whole machine presses at once. It's a Necker machine. And so they're making aluminum bottles like this. And so it comes in as a straight piece, you know, similar, not exactly like, but similar to this.
Sure.
And every one of those stations makes the neck a little bit smaller until you get to this. And so that whole apparatus will go in at once, crimp it, and then it indexes over one more spot, crimps it a little further. And since all those valves are firing at the same time, instead of using a 52, we decided to put a bigger valve, and we can run up to 8 stations. That's a 56, and we can run up to 8 stations off of one valve, which just cleans things up.
Very nice. Very nice. Excellent. Well, thank you very much, Aaron. Appreciate it.
Thank you. I appreciate you.